So when we finished our work, the last step will be just to, if you're going to write an article and published in a peer-reviewed journal, or you want making some just a thesis, bachelor thesis or master thesis, the last step is to create maps that are visually representative, and also if you're going to print them. So we have here all our layers and our final groundwater potential zones. So let's go to insert. No, let's go to view and change from data view to layout view. So see that the framework has changed, and we have the representation of a map which we can see in our day-to-day life. And the next step will be to change our layout. So there is additional buttons here, and we need this one, change layout. So I'm going to change it into this landscape format. So I think that this one is more visually representative and more attractive. So if you're going to move the map itself, the layer, you need to use this pen tool. But if you're going to move the window without not touching the map, you need to use this pen tool. So there are two pen tools. So, and I'm going to increase the map, the scale of a map, So probably slightly more, or we can use also this one. So if you're going to zoom the map, you should need again this two zoom tools. If you're going to just zoom the window, you need to use this one. So I think so far it's enough. And the next step will be to insert legend. So see that there are one legend items. If you just click this all layers, you will have all of the layers. In this case, you should uncheck or just use this tool in order to delete them from legend items. So forward, and I'm going to change background to 10%. So here is my legend. And I can increase it but I think that the value and groundwater potential zones are not needed here, and I want to delete them. So I'm pressing right button of mouse and going to properties. So go to items, groundwater potential zones, and I just uncheck show layer name and show heading. Click OK. Okay, so see that now I have only legend with colors which represent. So I can make it larger. So, and the next step is to add a scale bar, right? Can increase it, and we can change it, by the way, to kilometers, from miles to kilometers. And the next step is to add the north. So and the last step, I can add also the longitude and latitude to the bound to the my frame. So I'm going to properties again. No, I'm going to the data frame properties. So I have here grids, and I'm going to add new grid. So I will leave it the graticle divides map by meridians and parallels. So I have to change it now to appearance as labels only. So everything is forward and okay, but see that it's very small and invisible. So I'm again going to properties. So I'm now double clicking to graticle, and I can see the size, font size here. I can increase it to 36, and I'm going to make this vertical labels right and left. Just click label axis all, but label orientation vertical labels as left and right. So this part left and right will be my vertical orientation. Click OK. See that now it's more clear, so we can see that these are the longitude and latitude east side and the north hemisphere as well. So I'm increasing it. Now I can save the map, going to files, export. So I'm choosing this ArcMap, and I will write it. So it's a JPEG file. I will write it groundwater potential zones. And I'm going to increase the resolution into 300 dpi. So it's up to you what dpi you will choose. The higher the dpi, the larger the size of the image and higher the resolution and accuracy. Bear in mind that most of the journals, scientific journals, require at least 300 dpi. So I recommend you to choose this general options. So save. So now it's exporting. It will take some time because the image in our case will be large, because I increased the DPI into 300. So this is my map. Let's open it. So I think that it looks okay in general, visually representative. So in general, I can understand the length of the study area. So I can understand the legend, which color represents what. And this are also the longitudes and latitudes makes clear where it's located. So now we can repeat the same steps with other layers. So I'm deleting this one, and I will leave the same, all the same things, all the framework, but I need to change the legend. So again, do the same, change the background to gray 10%. Let's expand. So I'm again going to properties. So item slope, I'm double clicking and just unchecking show layer name and this one. So by the way, if you're going to understand the units, you can go again to properties and go to general, and in brackets I will write degrees, because a slope in degrees. So, and again, let's save it. Slope. So the options are the same. I'm saving. So it's saved. Now I'm moving to, I can delete this one. I'm moving to Savi. So I'm repeating the same steps. So let's expand it. And again, I'm going to uncheck show line name and heading. I don't need them. So these are just classes. So I don't need to write the unit. There is no unit here. Again, I'm saving it. Save. Precipitation. Legend. So the unit of the precipitation is in millimeters, right? Millimeters for 10 years. By the way, just a moment. By the way, we can also, I forgot to add, I forgot to add the heading title. You can add also a title, name it precipitation. And increase the font size. Going to change symbol. Let's increase it to 72. Okay. Precipitation and now again save it. So alignment. So I finished creating maps, and I can open my folder and again just check my maps. So this is classification for my study area. So depression in meters. So this is my final groundwater potential zones for my study area. Alignment density, precipitation, and SAVI. And the last one is slope. So this is our final results, and you can add them, publish them, your research as an article.